The Earth's auroras, commonly known as the northern and southern lights, Aurora Borealis and Aurora Australis, respectively. Auroras are visible almost every night near the Arctic and Antarctic circles, which are about 66.5 degrees north and south of the equator. In the north, the display is called Aurora Borealis, or Northern Lights. In the south, it is called Aurora Australis, or Southern Lights. Are a fascinating natural phenomenon caused by interactions between the solar wind and Earth's magnetosphere. Here's a breakdown of how they happen. Solar wind and charged particles. The activity that creates auroras begins on the Sun. The Sun is a ball of superhot gases made of electrically charged particles called ions. The ions, which continuously stream from the Sun's surface, are called the solar wind. This is made up mostly of electrons and protons that travel at high speeds through space. Some of these particles are directed toward Earth. Earth's magnetic field. As solar wind approaches Earth, it meets Earth's magnetic field. Without this magnetic field protecting the planet, the solar wind would blow away Earth's fragile atmosphere, preventing all life. The Earth has a magnetic field that acts like a shield, protecting the planet from most of the solar wind. Most of the solar wind is blocked by the magnetosphere, and the ions, forced around the planet, continue to travel farther into the solar system. This field is strongest at the poles and weaker at the equator. When solar wind reaches Earth, the magnetic field channels these particles toward the polar regions. Although most of the solar wind is blocked by the magnetosphere, some of the ions become briefly trapped in ring-shaped holding areas around the planet. These areas, in a region of the atmosphere called the ionosphere, are centered around Earth's geomagnetic poles. The geomagnetic poles mark the tilted axis of Earth's magnetic field. They lie about 1,300 kilometers, 800 miles, from the geographic poles, but are slowly moving. Interaction with the atmosphere. As the charged particles from the solar wind enter the Earth's magnetosphere, they get funneled along magnetic field lines toward the poles. When these particles collide with the gases in Earth's atmosphere, primarily oxygen and nitrogen, the energy from the collisions excites these atoms. Emission of light. In the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from Earth's atmosphere. The energy released during these collisions causes a colorful glowing halo around the poles, an aurora. Most auroras happen about 97 to 1,000 kilometers, 60 to 620 miles, above Earth's surface. As the excited atoms return to their normal, ground, state, they release energy in the form of light, which we perceive as the glowing colors of the aurora. The colors of the aurora depend on which gas is involved and at what altitude the interactions occur. The most active auroras happen when the solar wind is the strongest. The solar wind is usually fairly constant, but solar weather, the heating and cooling of different parts of the Sun, can change daily. Solar activity. Solar weather is often measured in sunspots. Sunspots are the coldest part of the Sun and appear as dark blobs on its white-hot surface. Solar flares and coronal mass ejections are associated with sunspots. Solar flares and coronal mass ejections are sudden, extra bursts of energy in the solar wind. Sunspot activity is tracked over an 11-year cycle. Bright, consistent auroras are most visible during the height of sunspot activity. More charged particles are ejected from the Sun. This leads to more intense and widespread auroras. Some increased activity in the solar wind happens during every equinox. These regular fluctuations are known as magnetic storms. Magnetic storms can lead to auroras being seen in the mid-latitudes during the time around the spring and autumnal equinoxes. Auroras have been visible as far south as the Yucatan Peninsula in Mexico. Magnetic storms and active auroras can sometimes interfere with communications. They can disrupt radio and radar signals. Intense magnetic storms can even disable communication satellites. Auroras at the poles. Because Earth's magnetic field lines are concentrated at the poles, auroras are mostly seen at high latitudes, near the Arctic, Aurora Borealis, and Antarctic, Aurora Australis. However, during strong solar events, auroras can be visible at lower latitudes, sometimes even as far south as northern parts of the US or northern Europe. Summary: the Earth's auroras are a visual result of solar wind particles interacting with Earth's atmosphere, creating beautiful lights in the sky, particularly at the poles. These lights are a reminder of the dynamic connection between the Earth and the Sun, and how our planet's magnetic field helps protect us from the charged particles of space.